Howdy folks, this is Sean and welcome back to the shop. I'm going to get started on a project here today and let's go ahead and get you introduced to it. This is, I've had this one kicking around for a while. This is an air mussel. I watched a YouTube video by our buddy Ave about these many moons ago, and if you don't watch Ave, you need to, and if you do watch Ave and you haven't seen this video of his, check out the doobly-doo down below, and I will have a link to that video of his. Anyhow, it was watching his video that gave me the idea of how to, or it did not give me the idea, he showed me how to make air mussels. And this is one right here, and pull a little bench compressor in here. Alright, this thing's loud, sorry. And I don't, that side it fits on, but that side is vacuum. Anyhow, so this is one of my first ones. I could take you out to the shop and use the blow-off tool in the air compressor, and you'd see this, you know, cinch up. But I can, stuff all over the place. I can bring in some smaller air mussel that I have made. That's a really long one. I'll show that one, get to that one in a minute. This one simply has the tubing pulled through. Here's one. This one will be good for example. And let's set this thing. I'll set this thing down here. Yeah, that's pressure side. Alright, so it's the same thing. The outside jacket is abrasion sleeving for wire or fiber optic cable. This is actually off of Corning fiber optic bulkheads with the tails out the back that you would use for splicing in a 12-pair trunk line to a bulkhead. So that's where this is coming from, and so you use a piece of wire abrasion sleeving. This is the same stuff, it's bigger. Let me look down here. Shrink and loom. It comes in all different sizes. This is some nice, really large wire loom sleeve. Another neat little trick with this stuff, you can have a big wire loom here, and you can get between the weave, and I'm not doing very good right here, but you can open up a gap. There, I've got my finger in there. You can open up a gap, run a feeder off of that to whatever you have that's at that point in the loom, and then back feed this piece of abrasion sleeving inside the loom, and have all of your wires in a loom covered with abrasion sleeving. Here's another piece, slightly smaller. That one looks like a snake. I'm a snake. Anyhow, hey, there's some in red, and I've got some big, huge heat shrink tubing here too. This is some really nice stuff. That's about 1.5 inch diameter right there. It will shrink to just under 1/2 inch and has the hot melt glue inside. That's just what happens to be in that box that I also have more of this this abrasion resistant wire loom stuff. Inside of that you put a piece of, this is silicone rubber. Inside of this tube here I've used medical grade silicone tubing. I'm pretty sure this was silicone. I will go back and look up what I ordered. I got this off of Amazon or one of those places. And anyhow, so that's how that's the makeup of it. You plug one end, and I used a piece of miniature connects here, stuffed it in the end of the tube. Here I used a large connects because it's a larger piece, but stuff it in the end of the tube, and then with a couple zip ties here, a single zip tie here, just zip tie it to make the seal. Up here I have a piece of, it's actually the straw from a spray nozzle from a can. I actually believe it is my can of deoxit. If you notice, that straw is a little shorter than it should be. Cut a little piece of straw, stick it in there, and then you can zip tie either side, and that gives you your pressure feed hose and then the air muscle. But to demonstrate, heck, for the most dramatic demonstration, we will use this nice big one right here. So this should just, constrict up like a snake. Alright, I'm going to plug this in. Again, this is going to be loud. So, headphones, warning, this is going to be loud. Maybe not that loud, but... Alright, so watch this. Yeah, that's the air pressure coming out. So watch this as I... So that tubing swells up inside the loom, but the loom contains it. It can't swell beyond a certain point, and as it expands, the loom has to contract in length, just because of the way it's woven. So that causes it to contract greatly along its length, which is how it works. And I was trying to figure out, this is what the video is going to be about. It's an animatronic tail that I'm building, and I was trying to figure out how to make air muscles with enough power. And power is really not an issue, but make air muscles with enough throw to operate the tail, because I had built the tail. Here, and I'll show you this one, and then I'll shut this off. Nice little demonstration right there. We'll set this out of the way. So I'll bring the tail in here. Get my VOM out of here. Get this box out of here. So this is the tail that I've made. I made this a long time ago. This is what gets strapped to you. It goes in the small of your back, which ties the tail rigidly to your torso. Double D ring style belts, 2 of them, and the D rings, the belt is sheathed inside of a sleeve that goes against you, and by leaving a tongue out here, it makes it so that usually this isn't going to be directly against your skin, but you're in a fursuit, you're most likely wearing a really thin underlayer of Under Armour type material, and you don't want this pinching you. So that's the closure mechanism to hold the tail tight to your body. You need it to be pretty rigid on your body. This needs to be fairly rigid in order for the animatronic and the motion of the tail, in order for this to actually curve up, this has to be rigid. You can see how I originally designed it. The vertebrae, or the spine for this is a piece of convoluted tubing or corrugated tubing. Oftentimes this one is white, oftentimes it is orange. It's fiber interduct used to run and protect fiber in communication huts. And just for fun and fancy, I wrapped it in another piece of that same abrasion sleeving, and the this piece here is made out of masonite clipboards, not just a big sheet of masonite. That's actually the clipboards that I cut up there to make that, which is very good and solid, and then a piece of foam and a piece of polyester material. Then there are also masonite vertebrae along the length of the tail. Every one of these nodes has a masonite vertebrae in there that has 3 holes drilled in it in a triangular pattern. One of them down the length, and then 2 down the sides. Ones down the side would pull the tail side to side, and the one down the way will curl the tail up. I did have this strung up with it's safety wire. It's just general steel, 16 gauge steel wire is what I had through this, and then they all pulled up here, and I was going to run those through a cable sleeve mechanism like you use for the brakes on a bicycle. And I was going to run those into a backpack and try to figure out how what kind of servos I needed because you have to pull fairly hard, especially once this has fur on it. You have to pull fairly hard to get this to move. And then I was thinking about air muscles. I was trying to figure out how I can have an air muscle with enough travel to pull that cable the amount that it needed to. And it finally occurred to me, the muscles in your body run through would be running through the tail. Well, actually, you'd have tendons running through. It doesn't matter. Run the muscle in the tail. I've already got a couple of holes here that I've opened up a little further, but I'm going to open these up, and I'm going to run the air muscles through the tail, and down here at the base, it's going to be anchored, and then up here at the top, I'll have to shorten this. It'll be anchored up here as well, and then just a piece of air line, 3 pieces of air line running up into a backpack that will provide air to them to move. Having such a short line and not being able to have the air pressure relief valve right at where I need to dump the pressure, so this is basically the end of the cylinder, the end of the pressure vessel that needs to vent, and it will be right here. Ideally, I should have a relief valve, 3 relief valves right here. I can push pressure in quickly. Letting it back out is what will go slow. So I'm not going to be able, because I'm not going to have the valves here. They're going to be at the end of what could be up to 3 feet of airline running up into my backpack. The tail will only have it won't have rapid movement, which I'm fine with. I'm completely fine with that. I have a feeling this is going to wind up working a lot better than I'm expecting. I'm optimistic. So, but that's it. That's the project we're going to be doing here. Air muscles and basic. I mean, and this is nothing new. This is nothing groundbreaking. My what would this be called? It's the something form. The exoskeleton, the endoskeleton of there's a name for this. The armature. I think armature is the word I'm looking for. This armature, this is nothing new. This is nothing groundbreaking. This is basic animatronics. But I'm trying to make it light because you have to carry it. You know, you're carrying this on you, and I'm trying to make the controls as small as possible so they can fit in a backpack. I've also got a basic cooling system that will take up about half of a backpack, so I'm trying to make the controls for this take up the other half, so that in a single backpack I can control my animatronic tail and the cooling system that I'm wearing, because fursuiting can get quite warm. So that's it. I'm going to get to work on this, and yeah, I hope you enjoy the project. Whee! Let's see, there's probably a better tip for that. What do we got here? Not much left of this, but it might actually be able to get into the nooks and crannies here at the beginning. I didn't think that was going to fit, but I was taking a chance. Let's see, what do I got over here for tools? We'll use these. Go ahead and put this in my little box over there that Dremel tips go in, because if I don't, it will wind up somewhere. I will never know. Toasted it. Ooh, that's hot. I should have known that. Yep. Alright, we will not put this back in the little box that Dremel bits go in, because I will think it's a Dremel tip and be like, let's see what this one does, and it won't do shit. And it will waste my time. Let's see, is this roughly the same size? Yeah, I can make the same size hole with that. Yeah, alright. Let's see if this works. I mean, nothing to do but to try it, right? Need to get some air in here. Hold on. Alright, open the window, turn on the fan. Alright, let's get back at it. Tres más, I believe. Right. So that was a lot more whoa than I was expecting, but there we go. Oh, a lot of dust. Are we still recording? We are. Yeah, we were still recording. I shouldn't have touched it. Anyhow, I'm going to do a little more stuff here, and then we'll be back to you here in a little bit. Out with the old, in with the new. Alright, I got one of these through here, and it's just unterminated at this end. This is the needle, or the fid, if you're familiar with that term, that I am using to pull through with. So, because getting it through the foam, you know, I've got the holes in the masonite. Got those holes, they're fine, they're sized. Getting through them's not a problem, but I have to push it through the upholstery foam. Apparently some of these I didn't make it through as well as I thought I did through all of the masonite. Yeah, there too. I think it's where there was hot glue on the back side. It didn't make it through. Yeah, that one's fine. And this is a stick, a stick off of a piece of old firework. I don't know if you recognize the sticks are usually red or this pink color, but that was the bottle rocket. Just a sharp, pokey thing, and some more of this material. This time with nothing in it. And here's the air muscle we'll pull through this time. Take us a little blue tape. That just holds all the little pieces down. It makes this step right here much easier. It's time for docking. We'll dock this inside of that. There we go. That's about 4.5 inches of engagement there. And then simply pulling it through. Making sure not to knock our soda pop over. That would be sad. Alright, and we are pulling the air muscle in now. And we are out. And this, I'm going to throw another zippity doodah right here. Damn it. And then another one right here. I'm just beefing this up because this is going to be pulling. This is going to be one of the sides that this muscle is anchored on, so one of the tendon ends, if you will. And it's going to just butt up right here. Alright, so that's came off the end down there, and I'll save that and use that for my last one. Alright, I shouldn't have made that hole as big as I did. So let's find something to put there. Yeah, I don't know what to exactly use. I don't need much, I just need something, need slightly bigger zip ties. Solución Especial. It's a little bit of neoprene rubber. Just wrap it around it. Zip tie that. That definitely will not pull through there. Alright, so show you how we're terminating the other end. Alright, I want that to be right there. So go ahead and mark where I want my end to be. Now this is all pretty tight now. It occurs to me, crap. That's why it never wanted to curl up the other way. is for that to curl there, this has to be loose. Alright, we'll see what that does. I don't expect that to work very well now that I've viddied it. I know that's not going to work well. Anyhow, we'll hook it up anyway. And then I take the connects piece that I've used to stop the end, push it through the hole, and then using another connects piece I can snap that on, and that will not, that's not going to pull back out. So yeah, it's not going to want to go side to side very well. Well, so what I can do, that one would work that way. It just won't side twitch that way. I could leave this one long on this side. Anyhow, I'm not sure. I'll think about that and come back to that. Right now, I've got an actual muscle in the tail, and I want to see how this is going to work. So, let's see here. Alright, turning the compressor back on, so headphone warning. Alright, Yorn Tech. Well, that definitely makes them twitch, doesn't it? I gotta keep going now, because that worked better than I expected. Alright, I'm gonna pull this one out because I want to terminate it the other way around. So, and I want to use one that's already plumbed in. So I'm going to use this one because it's got a nice big long hose on it. Cut this off the end. Alright, push our fid through. Yeah, same thing as before. If there was hot melt glue on the other side of the hole that I burned through, it didn't burn the back side out very well. So I'll go ahead and brush that out with my fingertips. There we go. Feel a little better about it now. Alright, we are in. No, I'm doing the sorry. I'm redoing the top. But hey, I've got those ones cleared out now, right? Good practice, good practice. I'm sure somebody's wondering why I've left this so long. Why didn't I just cut a short piece of this? And it's because why should I don't want to cut this yet because it's valuable material. And until I know exactly what I'm going to use it for, this is just a temporary use, using it to pull through with. So I will leave it long. Alright. Now we will pull this until we get to the end of it. We'll put some more zippity doodads on here as well. I don't want that one there. I'm running out of zip ties. I have to go grab some more. Be right back grabbing more zip ties. And we're back. Alright, grab another piece of this neoprene rubber. Alright. Bottom that out right there. Spin our tail around. Uh-oh. There we go. Apparently that tubing was under slight tension when I cut it and it jumped back inside. Oh. Making a mess of things. There's one. And two. Use a good pair of flush cuts when you're using zip ties. That way, whenever you're working on this in the future, you can't cut yourself. There's nothing worse than cutting yourself on a improperly cut zip tie. Shove that through the hole. Take the connects piece, snap it on. Alright. See how she do. Plug our compressor back in. There we go. Alright, so apparently I won't have a problem getting rapid movements out of it, because, well, at least the release that I was working out. And again, the sideways. I don't have a manifold over here, so I can only control one axis at a time. But he definitely can curl his tail up, so no question about tail curl. So there you have it. We'll get back to you as we get more done on this, get some fur made to cover it up. But that's it. That's the basics, proof of concept. Air muscle based animatronic tail. And as always, this has been KJ4 PTD 73s. And if you like this kind of thing, just not this kind of thing, but this kind of thing, or Christmas present, 3D stereo drawing pen, one of those little Air 3D printers, handheld pens. I don't know what makes it stereo. I've read the instructions. I can't figure out what makes it mono either, how to go from stereo to mono. Another Christmas present, got me some Kester 186, no clean flux. Needed some more flux on the bench. But yeah, whatever. I mean, take a look at my videos and the kind of things I do. All kinds of stuff here in the shop. Please leave a comment, ask questions. I love feedback. I love to talk. And if you like what I'm doing here, these kind of things, and you want to see more of it, hit subscribe. I plan on I want to start doing more videos and uploading with a little more regularity. I've had a YouTube channel for over 10 years now, and I haven't really been uploading that regular. So I want to start doing. I do all these kind of projects always, and I might as well have a camera running while I do it and share it with you guys. I enjoy it so much whenever I watch YouTube. So I figured I'd record a few of my projects and give back. So this has been Sean, KJ4 PTD 73.